See, we got a non-broadcast frame relay environment. Let me explain this. If you go inside frame relay, you can see a hub and spoke design. Let me explain with this background. Sniffing. See, a router can be converted as a frame relay switch. And I should not say converted. A router can be used as frame relay switch. That means it can be a router at the same time. It can be a frame relay switch, which I would have uploaded in various videos. For a change, what I have taken in the previous batch and in this batches, I'm taking the frame relay switch itself. Yeah, in the real world, the frame relay switch is a GUI based. This is how the frame relay switch will be, where I have taken port number 1, this one, and I connect to port number 2, this one. Likewise, port number 1 to port number 3, this one. Now, from port number 1, I'm forming 2 VPNs. Here we don't call it as VPN, here we call it as PVC, private virtual circuit. In some documents they also say permanent virtual circuit. So there are 2 PVCs. Now on port 1, I identify this tunnel point, endpoint, as 101, which goes to router 2 side. And the tunnel that goes to 3, I identify with 103. This is number given by me. We can give any number, doesn't matter. In real world, in the real frame relay switch, it will dynamically assign a number. This DLC number, we call it as DLCI number. Data link. Data link is layer 2, right? Data link. Connection identifier. Data link connection identifier is the abbreviation for DLCI. Now, fine. What about this side? On R2 side, I identify this as 102. That's the other end of the tunnel. And here 301. This is my way of giving number is if usually I give 102, 201, coming from 2 to 1. But here it is okay. That is just a number. I've given 102. Okay, now frame relay switch is ready. Only this much. You have put 2 connections, frame relay connections, frame relay circuit. What is next is we need to go to our router side. On the router side, if the router needs to talk to an Ethernet switch, if this is an Ethernet instead of frame relay, we don't do anything on the port side. All that we need is an Ethernet port. Ethernet port or fast Ethernet port or gig Ethernet port. Encapsulation will be Ethernet. But right now we don't have Ethernet switch. We have a frame relay switch. And frame relay switch don't have Ethernet port. They have only serial port. That's why we connected a serial wire. And this serial port, the default encapsulation is not frame relay. It is HDLC on Cisco router. If it is non-Cisco router, the default encapsulation will be PPP. This is what? Layer 2 encapsulation protocol on the serial link. If it is Cisco, Cisco's protocol HDLC, non-Cisco PPP. We have to now remove this HDLC and we need to replace it with encapsulation type frame relay. When we do that, what happens? This tunnel endpoint to reach this destination will be learned dynamically in a table called frame relay map. To go to this 10003, the traffic need to be sent to 103. That mapping will be seen in this frame relay map on R1, and that map get built dynamically. This frame relay map is dynamically updated using a protocol called inverse ARP. Inverse ARP. Through inverse ARP, the mapping between the del C number to the remote site is updated. Inverse ARP. Again, we no need to worry about inverse ARP, it gets enabled automatically. After this, we will go enable OSPF and see the NBMA stuff. Let's see up to here now. If you see by default, show interface serial /0, you will find encapsulation type as HDLC. But when I say interface serial /0 encapsulation frame relay, you will find a lot of DLC numbers, LMI type, local management identifier, all these are frame relay related stuff. And you see the encapsulation type is frame relay. Now, if I type now frame relay, show frame relay map, I won't see anything. The reason is the other end is still not ready with frame relay. This map gets dynamically updated, but it won't get updated until you go and enable frame relay on the other side. In fact, we have not even put an IP address here in R1. Let's put an IP address. Next. On router 2, interface serial /0, encapsulation frame relay, IP address 10.0.0.2. Likewise, I'll go to router 3, interface serial /0, no shed, encapsulation frame relay, IP address is 10.0.0.3. Now, see, there is no routing protocol, nothing in between. You will find frame relay map updated now. Okay, it takes some time, it will come. We have given IP address, we have enabled frame relay. Now, should not take this long. Show frame relay map. Oh, now only the interface is coming up, surprisingly. I don't know why. Maybe hereafter now we will get it. Show frame relay. Don't take this long. One is connected to 2, one is connected to 3. This looks good. Okay, what I'll do is I'll just refresh the interface by saying shutdown or no shutdown interface. Why the line protocol is not coming up? We can see that to go to 110.0.0.2, the DLC to which the packet need to be delivered from R1 is 102. Sorry, 101. Correct? No? That's what we configured here, 101. If the packet needs to go here, 103. So the router no need to be configured with DLC numbers. The router learns it dynamically through inverse ARP. As a result, if I ping now, ping 10.0.0.2, I'll be able to ping, as well as 10.0.0.3. So we got the PVC ready. Yeah, correct. But MPLS is not replacing the layer 2 standard protocols like Ethernet, or it can work with Ethernet, it can work with serial. Here you are totally changing the encapsulation type. The layer 2 itself is changed. You can see that here. None of these packets have got anything. See, when I ping, you see you don't have anywhere MAC address. Do you see any MAC address? No. You don't see any MAC address. You see straight away layer 3. So this frame relay encapsulation is totally using different IDs like DLC numbers instead of MAC address. Different technology. We totally changed the underlay. Okay. Now we are able to ping the remote sites. Now our goal is to check the OSPF side of it. I'll go to interface loopback and put IP address followed by OSPF. Also on interface serial /0. And now you see here, show IP OSPF interface brief. You can see OSPF is running on both. Likewise, okay. So even here I have enabled OSPF. Check show IP OSPF interface brief. And on third router, what next is we have to check whether neighbor comes or not. Neighbor will not come. Show IP OSPF neighbor, no neighbors. The reason you know it, show interface, sorry, show IP OSPF interface, serial 4/0. You know the reason. The reason is non-broadcast. Neighbors are not dynamically discovered. You have to manually give the, but we are not going to do this. We have tested all this thing in an Ethernet environment. Let's now switch to the fourth type of OSPF network type called broadcast. How to bring Ethernet experience in a frame relay environment. Usually, this is very rare scenario. In frame relay, we want to have Ethernet experience, like you want to have DRBDR, and you want to have timers to be 10 and 40, you know. So, and you want to have dynamic discovery of neighbor. So, how are we going to achieve this? Simple. Go to the interface, IP OSPF network type, force it to be a broadcast, though it is a non-broadcast. You're saying no, OSPF, you can send multicast traffic. You can send the multicast traffic. So I do that. Do it on all the route, interface serial 4/0 IP OSPF network type broadcast. That's it. Now you're going to see neighbors dynamically discovered. There will be DRBDR, all those stuff. But for this, you should have full mesh because if DR goes down, you should have another DR. Okay. Now, will it come? Yes, it will come. I'm waiting. It will come. We have changed the network type as broadcast. So where's the Wireshark? I want to see whether OSPF packets are going between this. Yes, I can see that. They already formed a neighbor. And I can also see there are DR. Otherwise, I won't see that 6 multicast address. You see, there is 224.0.0.6. Do you see that? So which means there is a DR. You know, see the first on top line. Router 1 is sending update to 6, which means router 3 is the DR. Now let us go verify on the command line. I can see one neighbor. Router 1 will have two neighbors because router 1 is a hub. Show IP OSPF neighbor. You can see two neighbors. As I said, router 3 is the DR and router 2 is the BD. Router 1 is a BDR in this case because router 2 is a DR other. But there is no use of this. You know why the hub goes down? These two guys are no more connected. So what you can do is you can go to frame relay and add another PVC. I'm going to say from port number 2, I would like to have a PVC called 203 and port number 3, 302. Alright, I have added another PVC. Now if you go to router 3, earlier we have only one neighbor, now I am expecting another neighbor. The neighbor will be with router 2. Show IP OSPF neighbor and also show IP OSPF, sorry, show frame relay map. Right now I have only one map to hub, but I'm also expecting shortly map to go to router 2. We just put the PVC, so it will come. Once the frame relay map comes, it will become full mesh when OSPF sends hello through the map. First, the frame relay should come. So let's now wait. I have cleared the map. Also, I'll do, no, let it be only here. Waiting for inverse R to come. There is no inverse R. ஒரு மேப் வந்திருக்கும்னு நினைக்கிறேன். ஒண்ணுதான் வந்திருக்கு. இது முன்னால இருந்ததுதான். We need another map. I can also write map statically because it takes time. I'm going to write statically. Interface serial 4/0 frame relay map IP to go to 10.0.0.2. Use the DLC number. I think we gave 3.0.2. Let me check that once. 3.0.2. That 2.0.3. Frame relay map IP to go to 10.0.0.3. Use the DLC number 2.0.3. This is from 2. And broadcast and send it. Done. I manually given a map. Show frame relay map. I have given, you see, statically given this one, whereas the previous one is dynamic. So I'm expecting at least now a neighbor. This ping should happen. Sorry. Why it is not happening? Which means the map is not working. Then OSPF won't come if the reachability is not there. I'm going to do something like this. I delete this. I make a fresh frame relay switch with a router. That will be more faster. But it will be confusing you. Better not today. Maybe some other day. I'll bring the same frame relay switch. So again, port number 1 has got 101 and 103. 101 connecting to port number 2, 102. One PVC is ready. 103, 301. 103, 301. Then port number 2, 203. Port number 3, 302. Okay. Now I'll also remove the static frame relay map which I don't want this static. I want the dynamic stuff. Only then we will have the line protocols, everything perfect. Protocol is good. I'll connect to serial 1. Show frame relay map. It will come. Show frame relay map. Okay, one has come, but there is another one to come. Show frame relay. One hub to the spokes is easy. But I want, if you hear there's no hub and spoke in first place. We have, okay, I think 2 has come. But between router 2 and 3 also, it has come now. It has come now. You see, dynamically learned. This is full mesh. Here, if you have DRBDR, no problem. And let us see the timer now. Show IP OSPF neighbor. You can see router 3 is the DR, router 2 is the BDR, no, router 1 is the BDR, and then router 2 is the DR other than. Now let us check this command show IP OSPF interface serial 4/0. You may see here, okay, the timer is 10 and 40. And the network type is broadcast. Even though it is a non-broadcast, we have made OSPF to work as it used to work in broadcast environment. So there is a DR. It says the DR is 11111. Sorry, the DR is 22222, and no, this is old DR. The current DR is 33333, and backup DR is 11111. So the router which we are in is DR other. DR other 2222 is DR other. This is broadcast. Now the last one is point to point. When do we need point to point? Let's assume you have here 20. Only in that case you need point to point. Not in same subnet. The neighbors are not in same subnet. And it is hub and spoke. Let's say you have hub and spoke. Here it is 20. We have 20.1 in one of the, we need to create subinterface for this. I'll say yes 4/0.2. For this, I'll say yes 4/0.1. And what we need is a point-to-point approach. So I'm going to remove the frame relay that we put to make it fully mesh. It's not needed. Okay, it is already in use. I cannot remove. Doesn't matter. Let it be there. But we want now point to point. So I'm going to start from here on router 3. I'll shut down. Then I'll say IP address is 20.0.0.3. This will override the previous one, correct? It will override. Now on router 2, I don't want to do any change. Next. I would like to bring it up. Done. No other changes on router 3 as of now. I'm going to router 1. In router 1, I'll shut down the interface S0/4 and remove the IP address 10.0.0.1 from there. Now what else is left in S4/0 encapsulation frame relay and no shutdown is still there. Correct? I just removed IP address to show run interface serial 4/0. You see, we still have the frame relay encapsulation, and we are going to change the network type that broadcasts into point to point. We are going to change it. Interface serial 4/0. I will also remove this. Also on router 3, I'll remove that. It will not cause any confusion later. Also in router 2, I'll remove. Okay. I removed broadcast and I'm saying IP OSPF network type point to point. Also in router 3, IP OSPF network type point to point. And then I bring the interface up here and also here. Now, on router 1, you don't need to say here the network type as broadcast or point to point. We are going to do under sub interface. But we need to make sure that encapsulation on the physical interface is frame relay and the physical interface is up. Dot one. Now, why it is saying incomplete command? Whenever you do sub interface on serial port, you have to say what type. Is it a point to point or multi point? I'm going to say it's a point to point. Now, encapsulation frame relay won't work here. It is only for the physical. We have already given. Now here I need to do what? I need to say IP address 10.0.0.1.255 0, 0, 0. Secondly, this is sub-interface, so inverse ARP cannot work here. Inverse ARP cannot work, so you have to put the frame relay map manually. But it's not the same command which I used earlier because it's point to point. It'll be like this: frame relay. Frame relay IP. No. Frame relay interface DLCI. So what is the DLCI to go to router 2? It is 101. This is how it should be done. Now I go to another sub interface. And then put the IP address as 20. And then frame relay interface DLC number 103. Okay. Next is running OSPF, IP OSPF 1 area 0. I also need to do it on the other sub interface. IP OSPF 1 area 0. Yeah. Now let us see the frame relay configuration. Show frame relay map. You see, it's a point to point. That's why the syntax was different. Oh, it is administratively down. The interface need to. Oh shit. Okay. Now we are expecting the OSPF adjacency soon. Okay, it is up. 101 and 103. And you see it is via the sub interface. So it now will behave like a normal point-to-point environment. We will have timers 10 and 40. We will not have DRBDR. It will be seen as point-to-point. Already there. You see, it is already there. It has formed neighbor with router 1. Let's check now. Show IPOSPF neighbor. You can see no priority, and you can see full mesh, full adjacency, which usually in only point to point, right? Only in point to point you will have full adjacency and no DRBDR, correct? Okay, show IPOSPF interface serial /0.1. You can see the timers are 10 and 40, and the network type as point to point. Right? That's